Hello guys, you might remember me from Our Future, Our Galaxy. I decided to go YouTube and set up a YouTube channel. Apparently you can gather more followers there, and people are in search the content that I provide on Facebook to a far more degree on YouTube. So I said I'd give it a go and see how it goes. I'm literally not going to be doing all this kind of flashy stuff that people do on YouTube, is where they would put up lots of descriptive stuff like pictorial stuff where they would talk through that. I'll try and just keep it very original, you know, just very personal, just me. I'll talk about my knowledge, my love for it. By the way, we're talking astrophysics there. I said I would I'd go from the very start, because that's how I done it on probably after losing some viewers already there, know the fact that I smoke, but the very same way I went on Facebook was I brought it to the very beginning, and the very beginning is it's the Big Bang. I'm not sure how many people are familiar. I guess this is why people do videos, is because people who do have some sort of interest and do want to learn more and do want to know more about these things, they would log on to YouTube and the likes and try and find out more about these things. I will guarantee that the information that I provide here will be accurate to the best of my knowledge, and it will be sincere, and I'm not looking to gain anything out of this there. It's just pretty much me wanting to share my knowledge and my passion for astrophysics. So as I says, I'll start at the beginning, and the beginning is, it's not substantiated. The evidence is quite overwhelming. I mean, when they terrorized, funny enough, theology and science have been, for a better example, have been at war with each other for a millennia now at this stage. Because scientists are ruling out a creator, and religion, theologians of all sorts, of all theologies, all religions have some form of God, and basically scientists, in the form of people who study the cosmos, they 99, I could say 100%, but I'm trying to be as accurate as possible here. Maybe there's somebody out there that still does believe in God, because there is a part of the story I'm about to tell you that not even scientists have an answer for. So at the very beginning, you have what was called the Big Bang. And funny enough, actually, a guy called Fred Doyle, and even more funny enough, it was terrorized by a physics priest. He terrorized it. He said that the creation of everything we see today started from what he called the primordial atom, and how they. It's quite a long story, and I don't really want to do a really big video, you know, and don't want to really kind of get into too much of it, you know. But George Lemaitre was a priest, a devout Christian, and he terrorized. He sent his theory to Albert Einstein, and Albert Einstein's response was, he says, your mathematics are fantastic, but your physics are incredibly off the charts. So basically, we're talking about the Big Bang, and funny enough, Fred Doyle was very like Albert Einstein, who believed in the static universe. The static universe is a universe that was always there, you know, it was unchanging. It was static. It was always there. It didn't have a beginning. It will not have an end. You know. When Albert Einstein terrorized his general relativity in 1915, he found in his equations that space had to be either contracting or expanding. And he didn't like the idea one bit, because he was a firm believer of a static universe. So he introduced a lambda, which is an ancient Greek symbol for mathematics, and he used it as a cosmological constant. And George Lemaitre took Albert Einstein's he took his mathematics of general relativity, and he said that he didn't ignore the fact that space had to be expanding or contracting. So he theorized that it had to have a beginning and then it started with a primordial soup. But like, theories are theories, and that's all they'll ever be, you know. That's just what people theorize, and theoretical physicists, that's their job. They come up with the best ideas that fit the best plans that are in place at the time. So basically, they had to find a smoking gun for this, you know, and there was several things that you know, almost proved that it's still not 100% substantiated, and it's not 100% fact that the Big Bang is the actual event that actually happened. What happened was, in a physicist, an astronomer, an astrophysicist, if you want to call him that, they built the biggest telescope up in Mount Wilson, which is in California. It was a 100-inch mirror, 100-inch telescope, the Hooker telescope it was called. It was built upon a mountain top there in California. An astronomer named Edwin Hubble. Before that, people looked to the skies and they used to see these things called nebula. Nebula is an ancient Greek for clouds, and nobody ever understood what they were. You know, there was an eccentric lord. Forgive me for not getting his name, but he was Irish, and he built in the 18th century the largest telescope, and he actually made the most accurate sketches of these nebulae, which were actually spiral galaxies. So Edwin Hubble set out to prove this, that they were actually they weren't a part of the Milky Way. You know, people thought that these nebulae gases were in the Milky Way, and the Milky Way was our universe. In doing so, what Edwin Hubble had to do was he had to find there's different ways of measuring large distances. There's the parallax method. I'll do another video on parallax for you guys soon enough. And then there's another way of finding a star that you're able to consistently know its brightness, and in order to do that, you have to find a star that's called a Cepheid variable. Now, a Cepheid variable is a pulsating star. By all means, it's not a pulsar. It's not dead. It's a very large A-type star. He found this in the at the time the Andromeda Nebula, which people thought was a gas cloud. Edwin Hubble, on the other hand, was a firm believer that it was another city of stars, so to speak. And he found this Cepheid variable that dimmed and brightened like clockwork. It was very consistent, and that fact alone allowed him, after many nights of observation, allowed him to understand and calculate its intrinsic brightness, therefore its absolute brightness. And when you know the brightness of a star, it gives you the determination to calculate the distance to that star due to an effect called the Doppler effect. And it works pretty much like sound converted into light radiation, in this case visible light. It's like, say, the pitch of an ambulance coming towards you. It gets high, and as it moves away from you, it gets low. This variable star, its light rays would on the spectrum go from blue to red. So when it dimmed, it obviously its light radiation was blue. It was low, and when it brightened, it was red, and therefore that allowed him to calculate the distance. He was only off by a factor of I think it was like a half a million light years. So he said that the Andromeda actually, in fact, is 2.5 million light years away. He said it was 2 million light years away, but therefore, nonetheless, that still proved that it had to be much further than our galaxy. Therefore, it was a star in another galaxy. And that was mighty scientific discovery at the time. He took that work from there. Then a Cepheid variable. Then it worked for a galaxy at the distance of the Andromeda, but it was no longer useful for determining the distances of further nebulas, which at this time we knew were galaxies. He needed to find a different type of an intrinsic brightness star, the absolute brightness of a star. You have the absolute magnitude and the absolute brightness. He needed to find actually both, in a sense. Therefore, he was familiar with supernova, and there's a couple of different supernova. I won't get into that. Again, that's another video. I'll be doing a few videos. Very original, very personal, very one-to-one, just like this. He was looking for type 1a, and I'll just give you a very quick synopsis on what a type 1a supernova actually is. Supernova, type 1a supernova is basically it's actually our sun, or we've a G-type sun in the main sequence at the moment. When it dies, it's going to expand up into a red giant. After a couple of million years, the stellar wind blows the gases away from what's left at the core of the sun, and what's left is highly dense, rich carbon, almost diamond like. It would be about the size of the Earth, which would be left. In physics, it's called a white dwarf. But it's very heavy and it has a lot of mass, and most stars come in binary pairs. If the star has developed, has died, and it's now in the stage of a white dwarf, it's extremely heavy in mass, and therefore it has a lot of gravitational attraction. If it has a binary star that is still in a main sequence, therefore it's able to start stealing gases off its a binary companion star, and it does this for millions of years. The white dwarf starts stealing all the mass off its neighbouring star, but there's a thing called the Chandrasekhar limit, and in physics, the laws of physics are the laws of physics. They can't. They're unchangeable. They're just the truth. They're the truth, you know. And there's a thing called the Chandrasekhar limit. Physicists, the physicist called Chandrasekhar came up with this. Well, not come up with this. He proved this. He known this. He used mathematics to establish this fact. When this white dwarf reaches its Chandrasekhar limit, it can only take on so much material that it explodes. No, for every type 1 supernova, every one will explode at the very same Chandrasekhar limit, and Edwin Hubble knew this, therefore allowing him to know the intrinsic brightness of that explosion. And he found one in a galaxy billions of light years away. And what he found was that, just like the Doppler effect that we spoke about, it was redshifted. And what I mean by redshifted is its light had taken so long to reach us here on planet Earth that its light waves were stretched out. Therefore, therefore giving us the information that explosion was moving away from us. Doing another few observations, finding another couple of one type 1a supernovas, he had found that all of the supernovas, type 1 supernovas, were being redshifted, and that meant that it was expanding. The universe was expanding. Einstein initially, in his equations before he introduced the cosmological constant basically said that there was an energy in space that counteracted gravity and made it static, you know. And in a way, in a sense, Einstein was right. You know, there is an actual energy in the actual in space itself. Like, space is not just space. It's not nothing. It's nothing. It's not nothing. You know, it's not just space, not empty space. It's actually filled with high amounts of energy. And Einstein publicly declared that it was the greatest blunder of his life, but therefore him being wrong, he's actually right, you know. That's how much of a genius he was, you know. His greatest mistake we turn out to be his greatest work, because we now know this energy in space itself as dark energy. We know very little about it at this time, but you know, I therefore believe that, like in due course, we will get to discover and understand, and we get a more fundamental understanding of what dark energy actually is. Yeah, so we know that the universe itself is expanding, thanks to the famous late and great astronomer, astrophysicist Edwin Hubble. Fittingly enough, they sent in 1990 on a rocket ship. They sent up the Hubble telescope, and fittingly enough, it was named after him. You know, there's a lot more to that story that I'm going to finish off. I'm going to leave it here. I just wanted to introduce myself. My name is Terence McSweeney. I'm currently studying astrophysics. I hope that was a bit informative. I'll leave a link in the description of how you can maybe follow me and maybe give me the thumbs up, maybe if you like what you just heard, or if you want to subscribe, it'd be great. I'll be only happy to bring more content your way, and I hope you all have a pleasant day, pleasant night, pleasant evening where you are in the world, and thanks for listening in. Peace out. Bye.